Good evening, dear students. My friends and fellows are present here. Which the day brings million happiness and success in your life. With respect to our previous class about the organic name reactions, we started the learning of haloform reactions. You know, dear friends, haloform reaction is one of the essential organic name reactions which specifically for the preparation of chloroform, bromoform, and these substances are used as the anesthetic materials in medical science. So as a chemistry students, we have to learn how a haloform is synthesized, already discussed in our previous video. Now today we are going to study what the requirement of a compound that responds in the haloform reaction. Specifically, the first and foremost condition of an organic compound that specifically can shows the haloform reaction, it must contains a ketomethyl group, that is such types of group CH3CO group, or otherwise there is also another condition, the organic substance may be converted to this group after a certain organic reactions on treatment with a suitable reagent. Already these problems already solved in our previous video. Now today we are going to discuss about that in spite of containing these types of ketomethyl group, there are some organic derivative also that never show organic name reaction, that is haloform test or haloform reaction. The first and foremost one is the acetic acid, acetyl, acetone, and there are other compounds also, acetamide, acetyl chloride, acetic anhydride. So today's question, the burning question is over here: why does acetic acid and acetyl acetone never responds in haloform test? Now dear friends, just look at the structures of this acetic acid and acetyl acetone. We'll discuss, we'll draw more details its structure. Now this acetic acid, CH3 C double bond OH. Here this carbonyl group is sp2 hybridized, one pi bonds are there, and look at the structure, this portion. So evidently it has a keto group and a methyl group. Still it never responds in haloform reaction. Why this happens? Okay, actually we know the kinetics, the actual mechanism of haloform reactions happens to the alpha halogenation reaction, or the substitution of the alpha hydrogen present in the methyl group. Okay, now if we treat the alkali, strong alkali, say sodium hydroxide, then it preferably captures this protogenic OH bond instead of this methyl group. Okay, the minus I effect of this carbonyl group is more effective for this OH group. Just look into the resonating structure. So this acetic acid, due to its resonating structure, look over here, CH3CO minus and O plus. This resonating structure shows that the oxygen possesses a positive charge, so this OH group easily broken instead of this CH3. Okay, so the minus I effect of this carbonyl group more effective for the OH group instead of alpha hydrogen. It is also the acetic hydrogen. That's why the first and foremost condition to substitute, if we try to substitute this alpha hydrogen, then immediately it produces the sodium acetate salt. Look here, this sodium acetate salt. Now once the negative charge or the electrons are accumulated along this carboxylic acid group, there is no opportunity to replace the alpha hydrogen of CH bond, because the minus I effect that was present before its deprotonation, now it is absent. So it is clear that this acetic acid will never respond in haloform reaction. It is clear, dear friends? Now I will discuss once again the another compound. It contains acetyl acetone group. Okay, acetyl acetone compound. Now look into the very beautiful structures of this compound. Acetyl acetone. Very interesting one, because this acetyl acetone behave as a ligands in coordination chemistry. It is synthetically very important, and even some complexes are prepared by using these ligands. So it has a ligating behavior. Now we draw the structure of acetyl acetone. CH3, C double bond O, CH2 and C double bond O. Now look over here, dear friends. This CH2 group, that is this methylene group, is connected with two keto group. So evidently it has two keto-methyl group. Still, it also fails to show the response, so haloform reactions. Okay, the answer is this keto-methyl group has a strong minus I effect. Strong, it's withdraw electron from this carbon and make this compound potentially acid. That is very strong acid. So very strong acid. This acetyl acetone group connected with this methylene group makes this CH2 bond very protogenic. So instead of replacement of hydrogen atom by this halogen bromine, it has the chance to replace at this alpha position. Okay, so that is why this CH3 group remain unaffected. These CH3 groups remain unaffected. Only these CH2 hydrogen atoms of this CH2 group replaced and produces CH3CO whole 2 CCBr2. Okay, now this cannot be generated. If we hydrolyze it in presence of a strong alkali, then it has the chance to be acetylysis. So this group may be broken. This group may be broken and it will produce CH3CO CBr2. Another way, if we treat strong alkali, more strong alkali, not only sodium concentrated sodium hydroxide or potassium hydroxide, then it has tendency to produce a carbene compound also. Then lot of compounds may be produced. So that's why this acetyl acetone also fails to show the haloform test. Okay, now once again we will discuss what about the acetyl acetone. Excluding this acetyl acetone, what about the acetamide and other derivative, acetic anhydride and acetyl chloride and so on and so forth. You will be amazed, you will be very surprised if you look into the detailed structure of acetamide. Similar situation will be arised. If we treat bromine and KOH in excess amount, bromine and KOH, the first and foremost condition of bromine and potassium hydroxide is the first and foremost condition of the to show it's the haloform reaction. But this compound, in spite of having a keto-methyl group, it never show the haloform reaction. It is prone to be what kind of name reaction, dear friends? You know, it suffer from Hofmann degradation reaction. CH3NH2 and potassium bromide and potassium carbonate salt is obtained instead of. So this acetamide responds in Hofmann rearrangement or Hofmann degradation reaction. Hofmann degradation reaction. Okay, Hofmann degradation reactions will be happen. So instead of replacement of this alpha hydrogen, it suffers from rearrangement reaction through what kind of? Through a isocyanate intermediate. Okay, through a rearrangement route. Okay, we will once again discuss more about details of Hofmann degradation reaction. It is also synthetically an important organic name reaction. So hopefully it is clear to all of you, dear friends. Now next day our incoming questions, just we will discuss in our next video that what about that acid catalyzed Haloform reaction, is it possible or not? Acid catalyzed, why acid catalyzed Haloform reaction is impossible, and other questions are there. We cannot synthesize fluorophore from this classical route.